We'll now illustrate the bold claim we made in panel B of graph 28.7. The claim was that we can move from a policy that's relatively close to the ideal points for three individuals in a two-dimensional issue space to a policy that's rather extreme through a sequence of pairwise votes if the agenda is designed appropriately. This is an example of a more general theorem that we've called here the anything can happen theorem. We'll illustrate only an example here, but the theorem is much more general and says that when you have at least three voters voting in a two-dimensional issue space, you can get from any policy to any other policy through a sequence of pairwise votes. We'll begin with three ideal points for three voters, and we'll assume, as we did in graph 28.7, that the only thing that matters to voters is how far away they are from their ideal point, but the direction doesn't matter. We then assume that we start at the policy A that lies at the center of the three ideal points, and our aim is to get to policy G. The first policy we'll propose is policy B, so we'll propose that we have a pairwise vote on A versus B, and the winner will then be put up against another policy. Since policy B lies closer to the ideal points for voters 1 and 3 than policy A does, policy B will defeat policy A. In panel B, we'll then propose another policy C that'll be put up against policy B. We'll need to be strategic in the sense that policy C will need to defeat policy B for us to make progress, and so we'll give up on voter 3, and instead we'll try to get voters 1 and 2 to vote for C over B. Since we've placed policy C closer to the ideal points of voters 1 and 2 than policy B, policy C will indeed defeat policy B. We'll next give up on voter 1, and we'll place policy D closer to the ideal points for voters 2 and 3 than policy C. Thus, in a pairwise vote of D against C, D will defeat C. Next, we'll focus on voters 1 and 3, and we'll place policy E closer to the ideal points of voters 3 and 1 than policy D. As a result, policy E will defeat policy D in a pairwise majority rule vote. We can then define the policy F that lies closer to the ideal points of voters 1 and 2 than policy E, and so policy F will defeat E. Finally, we can put our desired policy G up against F, and since G is closer to the ideal points of voters 2 and 3 than F is, G will defeat F. We have therefore defined the following voting agenda. Vote A against B first, the winner against C, then the winner against D, then the winner against E, then the winner against F, and ultimately the winner against G. And because we've been careful about how we've designed the policies in this agenda, we've been able to achieve, through majority vote, a move from the centrist position A to the much more extreme position G. It's easy to see how we could keep this going and get to more and more extreme positions through sequences of pairwise voting. This illustrates that in some sense there's nothing magical about majority rule voting. It can be manipulated unless preferences happen to be single-peaked and the issue space is only single-dimensional. And that means there's a real role for political institutions that can constrain this anything can happen result. We'll explore a model of one such political institution in graph 28.9.